Good morning, my dear students. In the previous class we discussed covalent bond and the types of covalent bond. In this class I am going to discuss one important concept, that is Fajan'S rule. Let us discuss Fajan'S rule. Before discussing Fajan'S rule, let us discuss, is 100% ionic bond possible or is 100% covalent bond is possible? Let us discuss. Is 100% ionic bond possible? See, when 100% ionic bond is possible, if the atom attract the bond pair of electrons 100%, then only 100% ionic bond is possible. But attraction of bond pair of electrons 100% not possible. When the atom attracts the bond pair of electrons 100%, if the other atom has zero electronegative, then only the atom attract the bond pair of electrons 100%. But no one atom has zero electronegative. That's why each and every atom has some electronegative. That's why no one atom lose the bond pair of electrons completely. If the atom has zero electronegative, then lose bond pair of electrons 100% and the other atom attract the bond pair of electrons 100%. But no one atom has zero electronegative. Each and every atom has some electronegative. That's why 100% takes up of bond pair of electrons not possible. That's why 100% ionic bond never possible. 100%. Okay, for suppose if a bond between A and B, these are bond pair of electrons. For suppose electronegative of B atom more than electronegative of A, then this bond pair of electrons attracted by atom B, attracted towards B, then B gets negative charge, A gets positive charge. But this bond pair of electrons attraction 100% not possible. Why? Because this atom electronegative value is not equal to 0. No one atom has electronegative 0. It has some electronegative. That's why 100% of bond pair of electrons attraction not possible. That's why 100% ionic bond not possible. Because no one atom has zero electronegative. That's why no one atom takes up 100% bond pair of electrons and no one atom lose 100% bond pair of electrons. That's why 100% ionic bond not possible. Let us discuss, is 100% covalent bond possible? Is 100% covalent bond possible? See, for suppose if a bond between X and Y, these are bond pair of electrons. If electronegative of Y greater than electronegative of X, then what happened? This bond pair of electrons attract towards Y. Then this bond pair of electrons near to Y, then Y gets partially negative charge, X gets partially positive charge. Okay, for suppose if electronegative of X equal to electronegative of Y, then what happened? This bond pair of electrons exactly center, then 100% covalent bond is possible. Exactly center. That's 100% covalent bond is possible. If electronegative of both atoms same, then the bond pair of electrons exactly at center. Okay, that's why 100% covalent bond is possible, but 100% ionic bond is not possible. So to explain the ionic character in covalent compounds, Fajan's introduced Fajan'S rule. To explain ionic character in covalent compounds, Fajan's explained Fajan'S rule. Okay. Here we are going to discuss three terms. First one, polarization Second one, polarizing power. Third one, polarizability. First one, polarization. Second one, polarizing power. Third one, polarizability. Let us discuss what is polarization. Okay, polarization is, for suppose, if a cation C plus, anion A minus, there is a cation C plus and anion A minus. This is now spherical shape. If the cation approaches anion, when the cation approaches very closely to anion, then what happened? The electron cloud of anion disturbed or distorted. Means these electrons, okay, attracted towards cation. Then what happened? This electron cloud distorted or deformed. Then like this. Now anion like this. This is polarization. What is polarization? When a cation approaches the anion, the electron cloud of anion is deformed or distorted. This phenomena is called as polarization. What is polarization? When cation attracts the anion, the electron cloud of anion is deformed or electron cloud of anion distorted. This phenomena is called as polarization. Okay, now we discuss what is polarizing power and what is polarizability. Polarizing power, it relates to cation, and polarizability, it relates to anion. What is polarizing power? Okay, the ability of cation to polarize the anion is called as polarizing power. The ability of cation to polarize the anion is called polarizing power. Okay, so polarizing power relates to cation. Okay, now polarizability, it relates to anion. What is polarizability? The tendency of anion to polarize by the cation is called polarizability. The tendency of anion to polarize by the cation is called polarizability. So these are the three terms: polarization, polarizing power, polarizability. Once again I explain what is polarization. When a cation approaches anion, the electron cloud of anion is deformed or distorted. This phenomena is called as polarization. And polarizing power, it relates to cation. What is polarizing power? Ability of cation to polarize the anion is called as polarizing power. Polarizability, it relates to anion. The tendency of anion to polarize or distorted by the cation is called as polarizability. Okay, let us discuss what is the relation between polarization and covalent character. Actually, polarization increases, covalent character increases. That means covalent character directly proportional to polarization. Okay, more the polarization, more is the covalent character. Okay, see, let us discuss cation. Polarizing power is directly proportional to charge on cation and inversely proportional to size of cation. And coming to anion, polarizability directly proportional to charge on anion and directly proportional to size. Let us discuss some examples. See, Na plus Mg2 plus Al3 plus. Which one more charge? Al3 plus. That's why polarization like this. Polarizing power in this order. Na plus Mg2 plus Al3 plus. Okay. Next, coming to anion, F minus, Cl minus, Br minus, I minus. Here charge same. That depends on size. F minus, Cl minus, Br minus, I minus. Which one larger size? I minus. That's why polarizability. F minus less than, Cl minus less than, Br minus less than, I minus. Polarizability. So covalent character directly proportional to polarization. More polarization or more polarizing power, more covalent character, and less soluble. Okay. NaCl, MgCl2, AlCl3. Here anion common, that is Cl minus. Now depends on cation, Na plus, Mg2 plus, Al3 plus. So which one more polarizing power? Al3 plus, more polarizing power. Then covalent character, NaCl less than, MgCl2 less than, AlCl3. Covalent character. Okay, NaCl less than, MgCl2 less than, AlCl3. So AlCl3 has more covalent character. NaCl has less covalent character. Why? Because here polarizing power less. Because here charge more, size also less. That's why more polarization. So more polarizing power Al3 plus more. That's why more covalent character AlCl3. Okay. Next one. For a given cation, covalent character increases with increasing size of anion. For a given cation, covalent character increases with increasing size of anion. For example, see, LiCl, NaF, NaCl, NaBr, NaI, sodium fluoride, sodium chloride, sodium bromide, sodium iodide. So here given cation Na plus. Okay, anion F minus, Cl minus, Br minus, I minus. So which one more covalent? I minus, larger size. That's why that will be more covalent. So polarizing power F minus less than, Cl minus less than, Br minus less than, I minus. Already we discussed. With increasing size of anion, polarizing power increases. That's why covalent character. This is covalent character. If you want to find ionic character order, reverse. NaF greater than, NaCl greater than, NaBr greater than, Na. Okay. So F minus. Similarly, for a given anion, covalent character decreases with increasing charge on cation. For example, NaCl, MgCl2, AlCl3, anion common. So cation Na plus, Mg2 plus, Al3 plus. Which one more charge? Al3 plus. That's why covalent character like this. Okay. So covalent character directly proportional to polarization, and polarization of cation directly proportional to charge and inversely proportional to size, and polarization of anion directly proportional to charge and inversely proportional to size. Directly proportional to size. Okay. Next one, cation with pseudo inert gas configuration has more polarizing power more polarizing power and has more covalent nature. Example, CuCl, NaCl. Okay, CuCl, NaCl. Cu plus in NaCl, Na plus. Cu plus, it has pseudo inetic gas configuration. Already we discussed in ionic bond. Pseudo inetic gas configuration means 18 electrons in the valency shell. Na plus, this is inetic gas configuration, 8 electrons in the valency shell. So Cu plus has more polarizing power than Na plus. That's why it has more covalent character. CuCl greater than NaCl. Okay. Similarly, ZnCl2 greater than CaCl2. ZnCl2 greater than CaCl2. Here Zn2 plus 18 electrons, pseudo inetic gas configuration. Ca2 plus 8 electrons, because Ca2 plus has inetic gas configuration. Argon, Ca2 plus, calcium 20 minus 2, 18, that is argon configuration. Argon means it has 8 electrons in the valency shell. Okay, Zn2 plus, it has 18 electrons in the valency shell, so it has pseudo inetic gas configuration, it has inetic gas configuration. So then Zn2 plus more polarizing power than Ca2 plus, hence ZnCl2 is more covalent than CaCl2. Okay, so these are Fajan'S rule. Okay, so according to Fajan'S rule, we have to find percentage of ionic character in a covalent compound or percentage of covalent character in ionic compound. Okay, 100% ionic bond is not possible, but 100% covalent bond is possible. Okay, these are Fajan'S rule. Okay, thank you.